This presentation is about digital multimeters for ham radio and electronic projects. What is a digital multimeter? Well, it's a portable handheld meter that measures voltage, current, resistance, continuity. It can do voltage drop of diodes, capacitance, and optionally the meter can measure frequency, temperature, and it also could perform digital logging. One of the other characteristics of multimeters is the resolution it can show. Here on the left is a 4-digit multimeter, and it can show in its 6-volt range down to 1 millivolt. So 2.500 volts is 2,500 millivolts. As you can see, the meter on the right has 5 digits, so it can show 2.5002, and that 2 represents hundreds of microvolts. So it has 10 times more resolution than the meter on the left. So in the meter on the left, it looks like you have exactly 2.5 volts. But if you look a little deeper with the meter on the right, you have not exactly 2.5 volts because it's a little higher by 200 microvolts. Another thing you have to do with digital multimeter is consider the counts along with the digits. A 3.5-digit multimeter means that 3 digits can do 0 through 9, but the 4th digit has to do less than that. And in this case, in a 6,000 count meter, the most significant digit can't be any higher than 6. So you can see that the 6.007 volts on the meter on the left, but when you go to 7 volts, it's 7.01. So you lose another level of resolution. On the 4-digit meter, which means it can use all 4 digits from 0 to 9, it's usually called a 10,000 count meter. You get the same resolution anywhere from 1 volt to 9 volts. It'll show you down to the millivolt. The next thing you have to think about is accuracy. And I know there's lots of numbers on here, but the really important ones are accuracy is rated as percentage of reading plus a number representing the least significant digit. And what that basically means is if you read 3.002 volts on your meter, you don't necessarily have 3.002. You have to work out what's called the uncertainty value. And in this case, we'll kind of skip through the math, but the uncertainty value is 18 millivolts. So you actually could have a voltage of 2.984 or 3.020. That's because you have to take the uncertainty value and add it or subtract it from the reading to see what the possible voltages could be based on the meter's stated accuracy. Another thing you need to think about with meters is safety. Electricity can kill you, and you use this meter to measure current and voltage, and it could kill you if you're not careful. Surprisingly, 50 milliamps can cause possible death, and anything higher is a more probable death. And so you got to be careful. One of the things they do for safety is they rate meters in categories for transient safety. So category 1 is things that are run off of batteries, not connected to the mains. So your 12-volt rig is considered category 1, and even though it is going through the power supply that's connected to the mains. Now the power supply would be a category 2 item, just like anything else in the house that is directly plugged in. Category 3 are your electrical system in the house, circuit breakers, switches, any equipment that's tied directly without a plug. And category 4 are entrances to the house, wires outside. Of course, in bigger buildings, it would be the distribution panel. So in general, I leave category 3 and 4 to the professional electricians, and I only use these meters for category 1 and 2. Now, to verify that a meter meets these category ratings, there's testing laboratories. And the 3 I've encountered in testing meters is UL, which is primarily in the United States, but does do Canada testing. CSA, which is in Canada, but they do testing for America also. And then ETL, which is primarily Europe, but they again do testing for Canada and the United States. So you want to use a meter that has one of these symbols on it, either a UL listed or CSA or ETL. And all the meters that I'm presenting here today have been third-party safety tested by one of these groups. Here's some safety tips. You should read the manual. Manuals sometimes have good safety information. You should inspect your digital multimeter to make sure it's not burnt, melted, cracked. You should also make sure you're using the right settings when you're going to use the multimeter. Don't have it in amp setting and the leads hooked up to the amp jack when you're measuring voltages, because you're going to short the circuit out and blow the fuses in the meter. Keep your hands dry. Keep cables and leads away from the heat source. I know you've probably never done this, but I have, as I've taken my soldering iron and accidentally put it in the wrong place and ended up melting the insulation off a cable. And that leads to trouble. You should double check your connections. Make sure you have things connected the way they should be so that you're doing the correct procedure for either voltage or current or resistance measurement. And with resistance measurements, you don't want to have the power on, because the meter supplies its own power to measure resistance. Avoid metal jewelry and work with a partner. I know with hobbyists, you really don't have a partner around, but if somebody else lives in the house with you, you definitely want to let them know, hey, I'm going to work with some electricity. If you hear any screaming or if you hear me fall down and hit the floor, please come in and see if I'm okay. Now we'll talk about some of the uses of a DMM and ham radio. Well, obviously a voltage check is a handy thing to do. In this case, I have a power supply that was sitting in storage for a couple of years, and to make sure it worked before I plugged the rig into it, I used the multimeter. Now, we generally call these 12-volt power supplies, but since it was based on automobile power, really it's 13.5 volts. And you can see here, 13.77 is okay. The most rigs, if you read the manual, say they'll tolerate from like 12 volts to 15 volts. So as long as your power supply is within that range, you'll be okay. Well, sometimes you buy resistors at the ham fest, you're not sure what they are. Sometimes, like me, you can't remember the color code. And I've been working with resistors since I've been 14 years old, and I still have a hard time remembering the color code. So it's just so much easier to use the meter to have it tell me what the resistance is. Another good thing to do is test your rig when you're planning on portable operation, or if you're worried about disaster recovery. You should know how much current your radio actually draws to compute how long you'll have use of the radio with your current battery. In this case, I'm using a 100-watt radio, so I need to have what's called a current clamp to go between that and the meter, because the meter can only handle up to 10 amps. And almost every meter is like that or less. And if they say they handle 20 amps, they'll always have a little disclaimer. Well, you can only do that for 10 seconds or only 30 seconds. Because if you overload the meter, it'll blow the fuse at least. So as you can see here, it's, or maybe not because it's pretty small, but it's 17.6 amps. So that's 100 watts into a dummy load. Another thing that's handy to measure, and not all meters do, but most of the ones I recommend do, can measure temperature, is I was testing my amplifier into the dummy load, and it's a air-cooled with temperature-controlled fans. And it was getting kind of hot and kind of smelling hot, and I thought the fan should have went on. So I wanted to measure the temperature in there to see what if it meets the threshold of turning on, so if I had to fix it or not. So yeah, it got pretty hot, but it turns out to be the fans did come on. Another thing is good to test is the ceramic fuses. Many fuses are opaque, so you can't tell whether they're good or bad. And with a multimeter, it's pretty easy to check them. Another thing that I use it a lot for is checking cables. This cable, I have it connected between the shield and the center conductor. And in that case, you should get an OL on the screen, which means it's so high of a resistance it can't measure it. But here I get a 1.6 ohms. So basically what that means is there's a short in this cable. And since it's 1.6 ohms instead of like 0.2 ohms, it's probably at the opposite end of the cable. So I have a good idea what end I have to cut off and put a new connector on. And I have lots of bad cables over the years that the meter has helped me solve. Now we're going to talk about some electronic projects that you could use the multimeters for. Here I built a little power supply board that takes 12 volts in and puts out 5 different voltages. And in this case, I'm measuring the minus 15 volt rail. Here's a case where the heatsink was getting really hot. And I wasn't sure why, and I wasn't sure exactly what the temperature was, because it's the design said it could be good up to around 50 degrees centigrade. So I measured the temperature to see what was going on, and it kept climbing higher and higher and higher, and it's got up to 60 when I decided, well, I think this is too hot. But I couldn't figure out why. Well, that's when the current measurement helped me again, because I put the meter between the power supply and this radio I was working on, and it's taken 906 milliamps. Well, that's way more milliamps than it was designed to take. And I figured out finally that because the changes I made, I substituted a much bigger LCD screen for the one in the book. LCDs use a lot more current than I thought. Okay, now we're going to talk about what not to use a DMM for. Just a couple things. If you want to test batteries, to really accurately test a battery, you should have a little load on it so you can tell what the voltage is with some current flowing. And digital multimeters are built to put as little as possible load on a signal as possible so it doesn't interfere with it. Most digital multimeters have 10 mega ohms or higher input impedance. So that's really not enough to draw any current from the battery that's meaningful. So a battery tester, though, has a load resistor in there, and it'll put enough of load on the battery so it can tell you if it's bad or not. Another one is GFI outlets. You really don't want to test those with the multimeter. It's really handy to use this little outlet tester. And you can actually push the little button and test if the GFI works. And you can get these from different manufacturers and get them at Home Depot or Lowe's, and they're only about 20 bucks. I've seen some of them from no-name Chinese stuff for about 10 bucks. If you want to measure small capacitance values, anything over 1 nanofarad, you really need to use a LCR meter. because the digital multimeters that I've tested, and I've tested a number of them, they just don't do very well with anything lower than 1 nanofarad. Their accuracy goes way down, and some meters can barely read it. So definitely, if you're going to do some electronic projects and you're going to get into those tiny capacitors, you might want to get an LCR meter. Now, I'm going to give you some meters I recommend. This is my opinion based on my biases, and take it with a grain of salt. Now, I do have reviews of some of these meters on my YouTube channel. I am going to be reviewing the rest of them and putting on the YouTube channel in the next couple of weeks. I kind of got behind with everything else going on. So let's get started. The first meter is the Unity UT161D. This meter is about $90. It's a 6,000 count meter. Has 0.5% plus 3 accuracy on the DC range. Since you get it from Amazon, you can get a 30-day return on it. And if you buy it from the Unity Direct store in Amazon, you'll get an 18-month USA warranty. You have to be careful. This meter is sold by lots of different vendors on Amazon, and the only one that provides USA support is the official Unity store, which is called Unity Direct. That's the only one that'll do that. There's other stores that pretend like they're official Unity stores, but they aren't. Now, handily, it runs on 4 AAA batteries, which you can get to by opening the battery cover, which has 1 captive screw that goes into a brass fitting. And also, very handy, is the fuses are in the same compartment as the batteries. So if you accidentally blow one of the fuses, it's easy to get to. Now, this meter met all the accuracy specifications for all the values I tested. This meter comes with a USB optical coupled interface, so you can actually run some software in your PC, Windows software, of course, that will talk to the meter and collect the data. This will also work under virtual Windows on a Mac. I tried that. It also will work with Bluetooth with an optional Bluetooth adapter that's pretty affordable, and it will work with your iOS or Android device. The major drawbacks of this meter is, in general, it has lower accuracy specifications, but it is the most economical meter, so you expect that. It has a dim backlight, and it beeps a lot. For some reason, Chinese meters, every time you move the rotary switch, it likes to beep. But this is a great meter for beginners. If you don't know if you really need an expensive one, or if you just want to upgrade your old analog meter, it's pretty good for $90. Now we're going to go to the EEV blog, BM235. For people who don't know, the EEV blog is a website that has lots of information about electronics. They have a massive YouTube channel that has information about electronics, and they have this forums with different sections about different parts of electronics. And the guy who runs it, Dave Jones in Australia, is pretty good with running this, and he's very knowledgeable about electronics and has very interesting videos. And part of supporting his system, he has a store. And in that store, he sells rebranded stuff. So one of the things he sells is this Bryman BM235, which you can't buy in the United States directly from Bryman. They don't, for some reason, Bryman doesn't sell any of their meters directly in the United States. It's always rebranded meters from other companies. And you can get this from the EEV blog store for about $115, or you can buy it off of Amazon when they have it in stock for $140. So if you don't want to go out to the Australian store. Of course, with Amazon, you get the 30-day return, and it's a 6,000 count meter. It has a 0.4% accuracy plus 2, and it has a 1-year warranty, but of course you have to send it back to Australia. It runs on 2 AAA batteries, and the fuses are accessible from the battery door. And again, the battery door has 1 captive screw, and I love the captive screws because I'm losing screws all the time. Now this meter met all its accuracy specifications and all the tests I ran on it. Again, you'll find this meter on my YouTube channel with a review, and of course the video review has a link in the description to the printed review. And then it also remembers the last mode selected on the rotary dial, because when you select things that have multiple options on that position on the rotary dial, most meters forget what you picked last time. It always sets you to the default. But this one will remember the one you used the last time. The downside of this meter is there's no logging. It has a dim backlight, and you have to send it to Australia for warranty work. But it is a little better than the UT161D because it's has more solid construction, better feel, has a little better accuracy, and it was built in Taiwan rather than China. Okay, the next thing on the list is the UT161E. This is kind of the bigger brother of the entry-level meter we had. And this again is available Amazon at the Unity Direct store for about $130. It's a 22,000 count meter, so it has a little more resolution. It has a basic DC accuracy of 0.05% plus 5. So that's a big jump in accuracy. It also has 30-day return since you're buying it from Amazon. And if you buy it from the Unity Direct store, it is 18-month warranty. Again, it runs on 4 AAA batteries, and very convenient that the fuses are also in the battery compartment. This is the lowest cost meter, which has 0.05% accuracy on the DC volts. And it meets all its accuracy specifications for all the readings I tested. It also has the USB optically isolated cable, so you can talk to the meter from your computer. Of course, it's only Windows software. And it has a reasonably priced Bluetooth adapter, so you can have it talk to your iPhone or iPad or Android device. The one quirky thing is this meter can't measure temperature. They decided not to put that feature on this meter. It has a dim backlight and it beeps too much. So this is kind of the higher resolution version of the UT161D with the commensurate higher price. The next one on our list, here's another one from EEV blog, and it's about $155 directly from the EEV blog store. Of course, you'd have to get shipped from Australia, or you can buy it from Amazon when they have it in stock for $200. So, you know, you're kind of paying a hefty premium to buy it through Amazon. It's a 60,000 count meter, and it has an accuracy of 0.03% plus 2. So that's getting up there in the accuracy level, and it's got a 1-year warranty. Of course, you have to send it to Australia. This has a little unusual 3 AAA battery holder that holds the batteries, but there's no way to access the fuses without taking apart the meter. Here's what the meter looks like opened up so you can get to the fuses. This meter met all its accuracy specifications with all the tests I gave it. This is another Bryman meter, so it remembers the last mode selected on the rotary dial. And this is one of the smallest and lightest 50,000 count meters. Some of the accuracy specifications are lower than the average 50,000 count meter, but since this is an entry-level meter, that's to be expected. And there's no logging. And again, you have to send it to Australia for repairs. But it's a great entry-level 50,000 count meter. The next one we have is a little stranger devil. It's a 50,000 count meter too, but it's not as accurate. And it has a 1-year warranty, and it's only available from EEV blog. Sometimes it's available from Amazon, but the last time I checked, it wasn't. They were out of stock. Didn't know when they'd have it in stock. And, of course, EEV blog has it. And I bought a meter from them, and it only took a week to get here. So it was a pretty good shipment and it was like $25 for the shipping. So it wasn't too bad getting it from them. It is interesting because it has 4 AA batteries, and it claims to have a 500-hour life on those batteries. And one of the reasons it needs it is because this is a logging meter, but the very interesting thing about it is it logs to a micro SD card, and the micro SD card is actually in the battery compartment. So you can store all kinds of readings in there without having to worry about connecting to a computer, and then you could pull it out later and read it on the computer. And of course, its fuses are also in the battery compartment, so that's pretty convenient. So this has a lot of good and a lot of bad to it. It met all its accuracy specifications for everything I tried, and it just so happens to be the most accurate meter I own for AC voltage. So portable meter, not the bench meter. The bench meter is more accurate, but this is all about portable. This too, even though it's not made by Bryman, it remembers its last mode selected. It has a setup menu, so you can change lots of things. So some meters you have to push a button when you turn it on to change one thing, but this one you could make the backlight stay on or choose how much time it'll stay on. You could make the auto power off, never power off, or you can pick whatever time you want. And there's some other options in the meter you can pick all from this little menu system they have in it. Has a secondary display that's pretty useful, and you can actually with the option menu change what it displays under certain modes. This is the only meter I've ever had that had a way to measure voltage and amps at the same time, and it'll multiply it out to give you volt amps. It's quite an interesting arrangement. And it also has a built-in aperture temperature reading, which very few meters have that either. And it does logging to the SD card, which I mentioned, and it also has Bluetooth built in, so you don't have to buy anything extra. So it'll log to your portable devices. Its accuracy in general is lower than most 50,000 count meters, but I believe that's because of the logging function, because in many of the higher accuracy meters that do logging, they claim that the accuracy of the logging data is less. And this meter seems to be dedicated to logging since it has its own SD card. So, but it's still pretty more accurate than the 6,000 count meters. The big drawback is it does not go higher than 600 volts. So if you want to do some boat anchor work with this, that might be a problem. But for anybody else, if you really need to have logging of data, you want to monitor something and not be around for a couple hours or however long, this is a good meter for that. Aesthetically, the red writing around the dial is really hard for me to read, and I've heard other people complain, and you have to send it to Australia for repair. But it's an interesting meter. I know it's a niche meter, but I wanted to make you aware of it because you might have a spot where you want to log a bunch of voltages or currents, and monitor that for a long time, and this is pretty much the only meter that'll do that reliably in a noisy environment because it does it right in its own micro SD card. Now this is the last meter, and this one is probably the kind of the riskiest to buy, but it's you have to buy it from Germany, and this is an actual branded Bryman meter, and it's their highest end meter. It's a 50,000 count. It has a 0.02% plus 2 accuracy, so it is the most accurate meter in this list. It has a 1-year warranty, but you have to send it to Taiwan. Again, this is probably a niche meter, but if somebody who really wants accuracy on voltages may want to get this meter. It's an older design that uses a 9-volt battery. And again, the older design, you can't get to the fuses from the battery compartment, so you have to take it apart. Here's what it looks like opened up so you can get to the fuses. And this, again, this meter met all its accuracy specifications for all my tests. It also remembers the last mode selected in the rotary dial because it is a Bryman meter. Has dual display with a bright backlight. So you can, there's a bigger number display, and then such as when you're measuring AC voltage, it also will tell you the frequency on the little tinier display up in the top right. It's the leader in accuracy specifications in most of the areas that are important. You can buy an optional USB interface that's optically isolated so you can log your stuff to a PC. Of course, it only works on Windows software. Unfortunately, there's no Bluetooth support, and you have to disassemble the meter to change the fuses, and you have to send it to Taiwan if you want warranty work. Here's a little overview of the voltage and current specifications. You can see that in general, the cheaper the meter, the less accurate it is. And the more expensive the meter, sometimes the more accurate it is. It's funny how the Bryman meters kind of split between the high-end meter is accurate in the DC voltages, and the lower-end Bryman meter is the most accurate in the DC currents. But anyway, just to make sure, the yellows are the least accurate of that range, and the greens are the most accurate of the range, and then the whites are everything in between. So if you want the most accurate meter of this list, it'd be the Bryman, the BM 869S. And that's, of course, the one you have to buy from Germany. I'd say the next one up is the EV Blog Bryman 786. And that you can get from Amazon. Of course, that you pay a premium buying it from Amazon, or you could buy it directly from the EV Blog store. But for starting out, I'd say the first 2 meters, the Unity and the Bryman 235, they're fine for the beginner, and you probably don't need more accuracy than that. And once you do, you'll have a very good idea what meter you want. So, you may buy the starter meter and keep it for years and not need to upgrade, or maybe you'll get into deeper projects and you want to upgrade it. But it's always handy to have 2 meters around anyway, especially if you want to measure voltage and current at the same time, or you need to measure 2 different voltages to see how they compare at the same time. Here is the accuracy comparisons for the resistance and capacitance. And the resistance, it still holds true that it's the more expensive meter. Usually it's the more accurate. But in capacitance, it's a little stranger. But again, some meters have trouble with capacitance, and they use a DC time constant way to measure capacitance, whereas LCR meters use AC and they use an impedance method to measure. So I hope this helps you pick a meter. And I have lots of meter reviews, and I like add one every week. And I have fallen behind because of other stuff that so I've missed some weeks, but I'm going to get back on track. And thanks for putting up with this. If you have any questions, feel free to ask.